Dear students, welcome to my 6th class on Module 5 Sampling Theory. In this lecture video, we're going to discuss few more problems on chi-square distribution. Example number 1. A sample analysis of examination of 500 students was made. It was found that 220 students had failed, 170 had secured third class, 90 had secured second class, and 20 had secured first class. Do these figures support the general examination result, which is in the ratio of 4:3:1 for the respective categories? So with the value they have given for chi-square is equal to 7.85 for 3 degree of freedom. So first we will take the hypothesis of the ratio 4:3:1. So now I am going to calculate the expected frequency of the given problem. So by calculating the expected frequency, so I'll be getting what? 4 divided by 10 into 500, the first ratio. The second ratio 3 by 10 into 500. The third ratio 2 by 10 into 500 and 1 by 10 into 500. So after simplifying this, you'll be getting 200, 150, 100 and 50. So now I'll be making the cumulative of observed frequency and expected frequency. So OI is actually what they have given: 220, 170, 90 and 20. And the expected frequency EI they have given like 200, 150, 100 and 50. So now I am going to check the hypothesis is true or not. So take the formula: chi-square is equal to summation I from 1 to n OI minus EI whole square divided by EI we are having. It will be equal to 400 by 200 plus 400 by 150 plus 100 divided by 100 plus 900 divided by 50. So after simplifying this, we got the value 23.67. But so this chi-square value 23.67, which is greater than 7.81 with respect to 3 degree of freedom. So hence we can say that the hypothesis is false, hence it is rejected. Next problem: 4 coins are tossed 100 times and the following data were obtained. So fit the binomial distribution for the data and test the goodness of fit at chi-square is equal to 9.49 for 4 degree of freedom. So here the data is like this: number of heads 0, 1, 2, 3, 4. Frequency is given like 5, 29, 36, 25, 5. So they have given observed frequency. We have to calculate the expected frequency by fitting the binomial distribution. So let P be the chance of getting his head in a single toss. So as we know that in tossing a coin one time, the possible outcomes will be either head or tail. So we'll be having two outcomes. So in that, choosing one head out of two outcome is 1 by 2. So we'll be having P is equal to 1 by 2. Since P is 1 by 2, Q will be equal to 1 minus P. So Q will be 1 by 2. And N is given by 4 and capital N is given by 1000. So now I am going to frame the binomial distribution. So from the binomial distribution, we have the formula P of x is equal to NCX, P power x, Q power N minus x. So replace all the data over here. So we got P of x is equal to 4CX, 1 by 2 whole power x, 1 by 2 whole power N minus x. So by simplifying this, we will be getting P of x is equal to 4CX into 1 by 2 whole power N. So now I am going to calculate the expected frequency with respect to x is equal to 0, 1, 2, 3, 4. So now, the frequency distribution will be obtained by small f of x is equal to n into p of x. So n is given by 100, 100 into 4cx into 1 by 2 whole power 4. So now I am going to replace x is equal to 0, 1, 2, 3, 4. So if x is equal to 0, the value will be 6. X is equal to 1 here, the value will be 25. X equal to 2, the value will be 38. X is equal to 3, the value will be 25. And x is equal to 4, the value will be 6. So replace the data in the table again. The number of heads, observed frequency, expected frequency. At x is equal to 0, it is 5 and 6. X is equal to 1, 29 and 25. X is equal to 2, 36 and 38. X is equal to 3, 25 and 25. X is equal to 4, 5 and 6. So now I am going to check the hypothesis. So chi-square is equal to summation I from 1 to n OI minus EI whole square divided by EI we are having. It will be equal to 1 by 6 plus 16 by 25 plus 4 by 38 plus 0 by 25 plus 1 by 6. So after simplifying this, the value will be 1.0786. So we got chi-square is equal to 1.0786, which is less than of 9.49 with respect to 4 degree of freedom. So since it is less than of this value, so hence the hypothesis is true, it is accepted. Example number, fit the Poisson distribution for the following data and test the goodness of it by using chi-square test. So the chi-square value is given by 7.815 for 3 degree of freedom. So x is given like 0, 1, 2, 3, 4. With respect to this x value, the observed frequency is given like 122, 60, 15, 2, 1. So now to check this hypothesis, first thing is we have to calculate the estimated frequency. So to calculate this estimated frequency, first we need to calculate the mean value to calculate the Poisson distribution. So here the mean will be equal to summation f of x by summation f. So adding all the values over here, so we got 0 plus 60 plus 300 plus 6 plus 4 divided by 200. After simplifying this, we got the value of mu is equal to 0.5. And in the Poisson distribution, we know that mu will be equal to m. So we got m is equal to 0.5. And from Poisson distribution, we have the formula for Poisson distribution is p of x is equal to m power x e power minus m by x factorial. So now to calculate f of x, the value will be f of x is equal to 200 into p of x. So hence we got the frequency distribution. To calculate the expected frequency, the formula is f of x is equal to 200 into 0.5 whole power x e power minus 0.5 by x factorial along with m is equal to 0.5. So now I am going to calculate the expected frequency by replacing the values of x. So at x is equal to 0 here, we will be getting f of x is 121. If x is equal to 1, f of x will be 61. If x is equal to 2, f of x will be 15. If x is equal to 3, f of x will be 3. So now make a table again with x and y expected frequency. So 0, 1, 2, 3, 4. Observed frequency is 122, 60, 15, 2 plus 1. And expected frequency is 121, 61, 15, 3 plus 0. So now I am going to test the hypothesis with the chi-square formula. So we have chi-square is equal to summation I from 1 to n oi minus ei whole square divided by ei. So this will be equal to 1 by 121 plus 1 by 61 plus 0 by 15 plus 0 by 3. So it will be equal to 0.0247. So this 0.25 is less than of 7.815 at 3 degree of freedom. Hence we can say that the hypothesis is accepted and it is true. Thank you.